So, if I'm writing the following in radical form and evaluating, then I'm going to say that this would be the same as the square root of 25 to the power of 3, which is the same as 5 to the power of 3, which is the same as 125. For example B, I have the cube root of 1000 to the power of 4, which is the same as 10 to the power of 4, which is the same as 10,000. For example C, it says that it's negative, so I have 1 over the cube root of 27 to the power of 2, which is the same as 1 over 3 squared, which is the same as 1 over 9. For example D, I'm going to have 1 over the fourth root of 16 to the power of 3, which is the same as 1 over 2 cubed, which is the same as 1 over 8. For example 8, this is the same as the cube root of negative 8 squared, or negative 2 squared, which gives me positive 4. For example F, this is the same as the negative of the cube root of 8 squared, which is the same as the negative of 2 squared, which is the same as negative 4. For example G, because they don't have the same base, I can't directly combine these, so I'm just going to have to apply it out. 3 squared gives me 9, 4 squared gives me 16, which is the same as 25 to the power of 1 over 2, or the square root of 25, which is going to give me 5. If I am dealing with a fraction with a power, remember it applies to the numerator and denominator. So this would be the same as the square root of 9 to the power of 3 over the square root of 4 to the power of 3. This is going to be the same as 3 cubed over 2 cubed, or 27 over 8. If I have a negative exponent, all that I'm going to do is I'm going to start by taking the reciprocal of the base, which means that that is the same as 4 over 9 to the power of 3 over 2. Remember, don't take the reciprocal of the exponent, just the reciprocal of the base. And then I get the square root of 4 cubed over the square root of 9 cubed, or 2 cubed over 3 cubed, which is going to give me 8 over 27. When I had the negative exponent, it's the exact same as my positive one. It's just the answer is the reciprocal. For example 3, it wants us to write an equivalent expression using radicals. Well, r to the 1/3 is the same as the cube root of r. S to the 4 over 7 is the same as the 7th root of s to the power of 4, or like this. Both are acceptable. For example, C, the first thing I'm going to do is get rid of the negative and say this would be 1 over t to the 1 over 6, which is the same as the sixth root of t in the denominator. And for example D, same thing. 1 over v to the 3 over 2, which is the same as 1 over the square root of v to the power of 3. Now, when it says explain why 3 of the above powers can be calculated but the other has no meaning, if I put all 4 of these into my calculator, only one of them is going to wind up saying error, or it's just not going to work. And that's going to be example D. And the reason why is if I have an even denominator, I should not have a negative base. We already stated that with the rules. I can't take the square root of a negative, so it's just not going to work. If I state that a cube has a volume of 60 meters cubed, if I'm writing a power which represents the edge length of the cube, then I'm going to say that the edge length is going to be the cube root of 60 in terms of meters, which as a power would be the same as 60 to the power of 1 over 3 meters. If this is what the edge length is, then the surface area of the cube, remembering that if you think of like a die, or that, which is a form of a cube, then it's going to be the area of one side, and then there's going to be 6 sides. So how would I state that? Then I'm going to say that in order to get the area of one side, it would be the edge length squared, which means that if this is the edge length and I want to square it, I'm going to take that and add a 2 in the numerator. And then what I'm going to do is I'm going to say that there's 6 sides. So I'm going to put brackets around it and say I got to multiply all this by 6 to find the surface area. Now, when I'm doing this, take a second, plug it into your calculator. If you're doing a rational exponent, you might have to put into your calculator 6 times 60 to the power of bracket 2 divided by 3. And when I do this properly, if I go to the nearest tenth, I get 92.0 meters squared. If I'm writing the number 10 in the following forms, if I'm doing it as a power with an exponent of 1 over 2, then that means that 10 is going to be the same as, if this would be square root, the square root of 10 times 10, or the square root of 100 So it would be the same as 100 to the 1 over 2. If I'm doing it as a power with an exponent of 3, then it's the same as 1,000 to the power of 1 over 3. Go ahead, try some practice.